from any kind of particle, converting from any kind of particle to moles, or going from moles to particles. It involves the same basic process. Okay? You're always going to use the relationship where 6.02 times 10 to the 23rd power of particles of some species, let's make it X this time, okay, is equal to 1 mole of that species. Okay? Where X stands for a specific substance. Alright? What can be particles? Almost anything. Mostly in chemistry, we're talking about things that have to do with chemicals, right? So it could be some kind of atom, molecule, ion, and that can be either a monoatomic or a polyatomic ion. It could be even something like electrons. That's all the kind of stuff we deal with in chemistry, right? And we can convert atoms, molecules, ions, and electrons to moles, or we can convert moles to atoms, molecules, ions, and electrons. But this is the equality statement we do that. You just have to know how to put your starting amount over 1, whether your starting amount is one of these particles or your starting amount is moles, you put it over 1, and you build a conversion unit from this relationship and convert. Same process. The canceling units, that's called dimensional analysis. We learned that in Unit 1. We started in Unit 1 doing that, okay? So we can give you a foundation for this part right now. All right? That right there?
No, down.
Here, right here, 1. Can you do what? Yeah. Okay? All right, so this is just reviewing what we just finished. I'm moving on to a slightly different subject, but we're still doing conversions here. Okay? What? So the basic process is the same. We're always going to need some kind of equality statement, and we're always going to put our starting amounts over 1. And we're going to build our conversion unit from that equality statement. Yes?
What was the problem of, what was it called that we just did before?
It's converting from moles to particles or back again. You could call it that. Okay? And when you did your mole rate project, those relationships we're using in this unit, you were supposed to include in your mole rate project. So your mole rate project should have had this relationship discussed. That was one of the requirements. Another of your required items in your mole rate project was the fact that one mole of any substance, 1 mole of any substance is equal to the sum of all the atomic masses of all the atoms in a formula. 1 mole of any substance is equal to the sum of all the atomic masses of all the atoms in a formula. It's in your packet. It's in. It should have been in your mole day project. Yeah. All right. So that allows us then, since this is an equality statement, see that equality right there, that equal sign? This is an equality statement, a general equality statement. We have to write specific equality statements for specific problems. what we're going to do is figure out how to use this now. Okay? So let's say I have 4.25 grams of carbon dioxide. And I want to find out how many moles is that. This will let me do that. Okay, I'm going to start with 4.25 grams of carbon dioxide and find out how many moles that I have in that many grams. Okay? Well, let's see how it works. Let's use this relationship and put it together. Okay? Well, this is going to be our starting amount. If it's our starting amount, what do we do with it mathematically? Put it over 1. Okay? I'm going to put it over 1. But now we need a conversion unit to convert from grams to moles. This is a conversion problem. We're converting from grams to moles. Okay? And we said that 1 mole of any substance, which means that 1 mole of carbon dioxide equals the sum of all the atomic masses of all the atoms in this formula. Well, we got to go and find those atomic masses on our trusty periodic table. Okay, we got carbon is 12.0107. So carbon's atomic mass is 12.0107. Oxygen's atomic mass is 15.9994. But we have to do all the masses of all the atoms, so we have to have another one, don't we? Okay, good. So 15.9994, and add the whole thing up. Yes, Shane? Yep. Do you still have your pass? Okay. Yes, and just give me a minute here, okay? So you'll add all these up in your calculator, please. Okay. Now I got that answer. Is that what you got? Did everybody put it in their calculator and practice?